Given the root of a binary tree, return the level order traversal of its nodes' values. Let's understand what that means with this example tree. At the first level, we have 5. At the second level, we have 3 and 8. At the third level, we have 1, 4, and 9. The goal is to group the nodes level by level, so the output becomes this list of lists. So how do we build this level by level structure in our solution? To solve this problem, we have two common ways to traverse a tree: depth first search and breadth first search. DFS goes deep first. It follows one path all the way down before backtracking, so it doesn't naturally process nodes level by level. So instead, we use breadth first search. BFS traverses the tree level by level using a queue. The code shown here is the breadth first search algorithm. This is the classic breadth first search traversal template. It shows up in many tree and graph problems, including the one we are solving today. It's a really useful pattern to recognize. So first, let's run it on this binary tree. We start by pushing the root node 5 into the queue. While the queue is not empty, we pop the front node and add its value to the output. We then push its children, 3 and 8, into the queue. Next, we process node 3 and push its children, 1 and 4. Then we process node 8 and push its child, 9. Finally, we are left with the leaf nodes, which we pop one by one and add to the output. As you can see, the output becomes one continuous stream of values. And that's exactly what a standard breadth first search gives us. So now the question becomes, how do we separate that stream into individual levels? So instead of storing only the node in the queue, we'll store two things together: the node and its level as a tuple. That way, every queue entry tells us exactly which level the node belongs to. We start with the root at level 0 and push it into the queue. When we pop it, we store its value in a dictionary under level 0. Then we push its children 3 and 8 into the queue with level +1. When we process them, their values go under level 1 in the dictionary. Their children are pushed into the queue with level 2. We continue the same process for the remaining nodes. Finally, we return the values of the dictionary as a list, which gives us the level order traversal. Let's talk about the code changes we will make to the breadth first search template. We start by creating a dictionary that groups values by their level. Then we slightly modify the BFS queue. Instead of storing just the node, we now store the node along with its level, starting with the root at level 0. Then we pop from the queue. We unpack both the node and its level and immediately append the node's value into the levels dictionary. Then when we push the children, we keep the same pattern and pass along level +1 for both the left and right child. And here we return the values of the dictionary as a list. And here are the time and space complexities.